beautiful here in Rocky Mountain National Park. I teach a class in the geology of the national parks, and we talk about questions like, why are those huge mountains there? And why are they made of rocks that were deep in the earth not that long ago, where it was really hot and they were sitting under some volcano? And then we talk about volcanoes and earthquakes and things that matter to people. And we talk about these great convection cells deep in the mantle that drive the drifting continents and the tectonic plates, and that ultimately are responsible for the volcanoes and the earthquakes that people worry about. We talk about the sun heating that mountain, and later in the afternoon that heat will cause the air to rise, and it will be causing big poofy white clouds, and those clouds may lead to hailstorms and tornadoes and things that matter to people. And when we talk about these circulations in the earth or the circulations in the air, most people say, yeah, get on to the exciting stuff, the volcanoes and the tornadoes that we're really interested in. We also talk about the fact that the sun shines through the air and heats the mountain, but the mountain is radiating longer waves, infrared, back to space. And because there's CO2 and water vapor in the air, we are warmer than we otherwise would be, because they are blocking some of that heat that the mountain is sending back to space. That CO2 in the air, we are raising because we're burning fossil fuels. And at that point, a whole lot of people who are very happy with convection currents in the mantle or in the atmosphere start to say, wait a minute, how do we know there's CO2 in the air? How do we know the CO2 is blocking heat? How do we know that humans are raising the CO2? Does that matter to us at all? And we get off on a discussion of technical points of science that people are very happy to accept similar things when it doesn't matter to them as much. Now, the physics of the atmosphere are in many ways easier than the physics of what's underneath our feet. What's under our feet, our understanding of these convection currents in the mountain building, is based on work by hundreds, thousands of scientists working over decades, proposing new ideas, making predictions that differ from predictions of other ideas, and seeing which ones work, throwing away what doesn't work, keeping what's left as a provisional estimate of the truth, and moving forward, and that's science. The physics of the atmosphere is based on work probably by more scientists working longer. The greenhouse effect of our CO2 has been understood for more than a century, and it's really based on physics that was refined by the Air Force right after World War II. Now, the Air Force wasn't doing global warming. They were doing things such as heat-seeking missiles. You can see the infrared coming from the hot engine of an enemy bomber, and if you have the right sensor on your missile, you can follow that and shoot down the enemy. But if you have the wrong sensor, CO2 blocks that radiation. There's a little bit of radiation comes down from enemy bombers. There's much more comes up from the sun-warmed Earth. The CO2 in the air doesn't care what made the radiation, it interacts with it. And so the physics of how greenhouse gases warm the Earth, of how our CO2 warms the Earth, is really, really solid. And it's been known for a very long time. And that, plus the fact that we in the US are putting up something like 20 tons of CO2 per person per year, is really all you need to know to realize that this matters. So let's go and take a look at the really solid physics and what it means.